Hey everyone. So I'm a dope and forgot to record the lecture on Monday, so I'm really sorry about that. And then I totally meant to do it yesterday or Tuesday, and then I forgot about that too. So really sorry for the delay on this, but I wanted to get you some recorded information for any of you who weren't able to make it to lecture on Monday or just wanted to refresh yourself on what we talked about. I'll cover it all here for you now as quickly as I can, and then you should be well prepared for your exam next week, and a little bit of a review of what we've gone through this semester and some things you should be focusing on for said exam. So first and foremost, I know motivation's getting a little difficult these days. Your faculty have recorded a really amazing video for you, so it'll make you smile, it'll make you laugh. It's just a perfect snapshot of the faculty you have in this course or in your programs. They are pretty amazing people. They are a daily source of motivation for me when I was a student and still now. So we're all very lucky to have such passionate, dedicated people to learn from. That video should have been sent to you, and just watch it anytime you need it. For me, I wasn't able to figure out my technology to be a part of it, but I've been posting on social media. If you want to follow me on Insta at Trees, Bees, Fungus. Been posting lots about my dogs and just fun stuff to hopefully make you smile. Today I wore my happy shirt and put on my tree necklace and just doing the things that I need to do to keep myself in a good mood and up and going. For me, that's pretty easy. But I know for some of us, I mean, we're all having tough days and feeling the crunch of this, isolation and feeling it difficult at times. But just remember, as far as the school year goes, you're almost done. Like, you can do this. You've got it pretty well licked. And as far as, the rest of life goes, we're all in this together. We are saving lives. Like, what we're doing is really, really important. I know it's not easy, but it's really, really important. So from someone who is so lucky, because all of my family is healthy, right from my 4-month-old cousin to my 88-year-old grandfather. We're all doing well, and that is because everyone is taking this seriously. So from the bottom of my heart, thank you for doing this to help keep myself and my team and my family safe. It really, really makes a difference. So whenever you're starting to get down, just remember we're making a real difference. Okay. Do the things you need to do to keep yourself happy, whether it's, putting on your smiley shirt or just putting on a smile. It does work. Or, getting goofy, putting on music, doing some yoga, doing some stretching, getting outside, whatever the case may be. Watching goat videos on YouTube, always good. Always good. Okay, do the things you need to do. Hang in there. You can do it. You're almost through your semester. Okay, and email me anytime if you need some help or a pep talk or anything at all. As far as Woody Plant Propagation goes, we still have things streaming ahead in the greenhouse, which is amazing. So huge thanks to Dan. Once again, I know I've been singing his praises every week, but he's really taking care of everything at this point, and I am so grateful for that. And I know all of you are as well, so I've been thanking him on your behalf. But he sent me these photos of the vegetative propagation, so you can see that things are really starting to happen. We've got flush growth growing from the top or out of the buds, and we've got root growth coming from the bottom of the cuttings. So these really and truly are baby trees at this point, and are not far at all from being planted. So on the far right hand side, we have the curly willow, which we're really excited about because that was an experiment for us this semester, and you can see the roots coming out of there and doing well. So everything is seeming to do well in that experiment, and there's not really much difference noted from the cuttings with the rooting hormone to the cuttings that had no rooting hormone. So that's always an interesting thing, but especially where willow is concerned, the chemical in the rooting hormone is actually derived from willow. So willows are pretty good superstars as far as vegetative propagation goes. So that's not testable. There's no assignment to do with the vegetative propagation, but we said we would bring you along for the ride so you can see that we have good root growth happening there. So pretty cool asexual propagative experiment. Now, let me make sure I can do this. There it goes. Using some new technology here. So details for your final exam for this course. It is going to happen on Thursday of week 15. So that's Thursday, April 16th. The test will be on D2L. It is open from 9 a.m. to 1 p.m. But once you sign in, you only have 65 minutes to complete the test. So please do not go in just to like test it out and make sure it works. If you have access to D2L, the test is going to work. Once you go in, you're committed. So there'll be 45 questions. They're multiple choice and true and false. And like I said, 65 minutes to complete it. They are very specific questions. So more specific than I would have created for your test if it were just in the testing center. However, it is an open book test, so there's no way we can prevent you from using resources. So instead, we're just going to encourage you to use your resources. You can use anything that you want, and I have the breakdown of questions here somewhere. Yeah, so of the 45 questions, 20 of them are going to be from the midterm, so weeks 1 to 5, and then the remaining questions from this half of the semester. We're going to have 8 questions about the pest control lecture that we went through. We'll have 12 questions about tree seedling storage and handling once we're done with the hardening phase in the greenhouse. And then there are going to be 5 questions on excuse me, on assignments that you've completed this semester and the experiments that went along with them. So the entire semester is testable. I definitely recommend studying, because if you don't and you just rely on having your resources, you're going to run out of time pretty quickly. So those of you who have accommodations for extra time, you have been allotted extra time. And, you know, we understand, your entire faculty team understands that there are lots of strange situations going on. There's lots of external stresses and just different things. So if there is any reason you feel that this will not be doable for you, we do have alternate options, and we can add more time for anyone who feels that it's going to be necessary. So please feel free, reach out to myself or your lab faculty, and we will work with you to figure out a solution that works for your particular situation. So we're, you know, still being flexible, and we're prepared to help you as much as we can be successful this semester. So please don't be afraid to reach out. I don't want to, none of us want to put any undue stress on you. So if there's something we can do to work with you to ease that, then let me know, or let us know. Same thing, you know, if you are working that day or have a huge assignment, you know, we tried to coordinate with your faculty from other courses, but if there's any sort of conflict, just give us some notice and we can figure out a solution. That's why we're letting you know with lots of time, or at least Monday I thought I was letting you know with lots of time, but really and truly we can get it figured out, so don't sweat it there. But those are the details for your test. So to get into there, what you'll do is just go to the course page on D2L, click assessments on the top, and then from the drop-down menu you'll select quizzes, and the quiz will be open on the 16th at 9 a.m. Unless we figure out a different day, in which case it'll be open for you on the day that we assign. So you can't see this very well here, but I sent you all an email, and this is a link, so you can access this from the PowerPoint that's posted on D2L or from your email. And this is just a link to a Google form to give us your non-Fleming email, so that when all this craziness is over, we can get back into the greenhouse, we can get you your trees. So we'll need to be able to contact you to let you know when that's happening and how that's happening. So we have no idea when it will be. Let's plan for it not to be for, you know, a few months yet. The trees won't be ready until June. So it won't be until June at the very earliest, but if the school's not open then it's going to be even later. So we're just planning ahead. If you can submit this with, like I said, non-Fleming email, you have an option to put your phone number in. You don't have to. I'm not going to send you any spam or anything like that. It will only be, your information will only be shared with the people who are caring for your trees. So please make sure you get that to us so that we make sure that when all of this is over, you get to take trees home and have some benefit out of it. So now to the meat and potatoes of our lecture today. So we're just going to go through a quick review of the entire semester. This is certainly not going to be adequate to be your only source of review for your exam, but it'll give you some good talking points and refresh you on some things that we've talked about. So this process of taking a tree seed and growing it into a tree is pretty amazing. I think that you've probably noticed that I'm pretty into it by this point in the semester. I hope that you found it interesting as well. So we're just going to review some of the concepts that are included in this amazing process. So starting with the seed, you've seen this image before, but the different parts of the seed, starting from the very interior, we've got our embryo, or it's also called a plantlet. And there's one part of this diagram that's missing, or one, I guess, label that's missing on this diagram, and that is the pointed end of the embryo. So towards the left-hand side on the opposite side end of the cotyledons, that is the root radical. That's what emerges first, just to remind you. Then we have the cotyledons at the top, so those are the pseudo leaves, so the false leaves that come out first, and then moving from the embryo out, surrounding the embryo is the food storage tissue. So what is going to feed the seed until those cotyledons come out and it starts photosynthesizing. Then we've got the seed coat to give everything, all the juice, a protective coating so that damage is prevented. Then on the outside of that we have the seed wing, and that is really variable. You saw in lab we did the jack pine, so you saw that seed wing. Just give it to, some coast so that it goes further. Think of a maple key as well, or a samara. Same sort of idea. That's the wing, and the wing just helps that seed travel further, so it's not just dropping from the tree and you have, a bunch of baby trees coming out from around the parent tree but nowhere else. So they don't have legs, they don't have wings, they need to be able to spread themselves out. Yeah, there's the food storage tissue. Okay. So then we also talked about seed zones. So remember for your growth progression assignment that seed zones and the seed lot number are not the same thing. So the seed zone refers to the geographical area where the seed comes from, and that's important because seed is genetically adapted to the area where it comes from, so that is where it's going to grow best. The seed lot number just has to do with the collection of the seeds, so it's more of a batch number. So those pieces of information that you need for your growth progression submission both come from the seed requisition form that we looked at in week 1. So if you still have your week 1 handout, that's where you're going to find that info. But talking about the seed zones, so just as a reminder, in Lindsay, where we're growing our trees, we're in zone 34. Most of our seeds that we're growing this semester come from 34. There's one that comes from 31. I think that's it, if I remember off the top of my head correctly. But basically, your best bet is to grow seed from the same seed zone that you're going to be planting it in. And if that seed zone isn't available, then try and just go 1 or 2 out, and that will give you the closest genetic the highest chances of genetic success that you can get for your area. All right, so once the seeds go to the processing plant, the wing is removed, they're cleaned, they're put through some testing to make sure that they're viable, then they're frozen, and when we get them, it's time to wake them up, so get them out of that dormancy or that frozen period, and as a refresher, that process is called stratification, and stratification has 2 steps. The first step is soaking the seed. That's what's happening here. And some places, when they soak the seed, will leave some airflow. So that's what this tube at the top of the bag is doing. And then you can see in the bag here. So just a good soak. This can be done in bags like this of water or just in damp paper towel. So you soak them for 24 hours and then you leave them in the fridge. So they need to be soaked and chilled. And this mimics the natural stages that the seed would go through in the winter and the spring. So it freezes, then it gets soaked, and then it chills for a while. Ideal temperature for chilling is about 5 degrees Celsius, so that works well because that's what most fridges are right around. And the amount of time that the seed has to spend in the fridge is totally dependent on species. So it's anywhere from no time, jack pine really doesn't need stratification, as some of you learned with your Petri dish assignment, all the way up to about 90 days. So around here, a white pine is about the longest, and it needs 3 months of refrigeration. And the effect of that is a more consistent growth. So just as a refresher for this, I know some folks struggle with this every year, but this is where we look at the germinative energy versus the total energy. So on the left, we can see no stratification. We still get decent growth, but it takes longer and it's not as consistent. So if you look at the peak germination, or germinative energy, so where we see that peak happening, basically what we're looking for these days with our curve flattening out, but with regards to seed growth, the germinative energy just talks about the best of the best. So this is when the most amount of seed germinates as quickly as possible. And when we're growing hundreds of trees or thousands of trees in a production greenhouse, we really want our trees to grow as much as we can, as fast as we can. So these are the best of the best seedlings. And then our total germination usually isn't much higher than our peak germination or our germinative energy when we've done the stratification, but it's much higher than the total germination when there's no stratification for most of the species. So this graph really shows us, or this comparison really shows us, the importance of stratification for nice consistent growth, and that slight difference between the germinative energy and the total germination. So sometimes, you know, we might be on such a tight growing schedule that it's not worth it to wait for that extra bit of time for the total germination for marginally more seedlings. We wait to the germinative energy point and then we scrap everything else because we want just the best of the best. So then once we're actually putting seeds in soil, we have 3 growth phases in the greenhouse. So we have the establishment phase first, then rapid growth, and then hardening. So we'll just do a quick review of what happens in all of those stages. My dog has fluff all over her nose, so it's, sorry, she's always making me laugh. So basically, when we look at the 3 stages, here we have a growing plan from a greenhouse in Inner Mongolia, and this is very similar to the growing plan that we've had this semester in our greenhouse, obviously very far away from Mongolia, but we did in February and got through our establishment phase at that point. Then come March, we moved into rapid growth. We're still in that phase now. We're actually in that phase until after you graduate. It's not until May, excuse me, that we start the hardening process, or the final phase of greenhouse growth. Oh, I knew I should have grabbed water before I started this, sorry. Then, along the bottom here, the bright green cells, those just say or tell us when this crop would be ready for planting. So our crop will be good for planting all the way from June through October. So don't sweat it. If you can't pick up your seeds until August, September, October, still no big deal. You can get them planted. In fact, fall planting usually is better for the seeds that, or the species that we grow. And you know, worst case scenario, we can't get you back in to get your seeds until next spring. That's okay. We'll overwinter them for you. Okay, so this is just one example of a growing plan that you can see those different growth phases. And then it can be manipulated. So this is just the same thing, but the seeds weren't started until April. And really, it depends on who you're selling the trees to and when they want to plant them. The nice thing about having a production greenhouse and growing indoors is you can manipulate all of those factors affecting growth that we have talked about and we'll review in a little while. And that just means that whenever your buyer wants to buy trees, you can backdate and start it when you need to and have trees ready to go all year long, maximizing your profits and space. So it's nice in that sense that knowing this process, being familiar with all of the experiments that we've gone through this semester can really help you be as successful as possible in the greenhouse business. So we can establish rapid growth and hardening phases. So same idea, just different timing. All right. Specific things that we provide our seedlings during the germination phase. So this covers the pre-treatment, so the stratification and germination and early growth. So when we first put our seeds in trays, I know that feels like a long time ago now, we covered them with plastic, as you may remember. So we didn't give them any fertilizer, we just gave them water. We covered them with plastic to keep the humidity high, because you want to maintain very high humidity in the germination process. And we kept the temperature consistent, so we aimed for about 25 to 27 degrees day and night. And then in the early growth phase, so as soon as there's something popping up, some growth happening, we took the plastic off. We changed the temperature a little bit. We went to 20 degrees during the day and 16 degrees at night. And we started feeding the trees with a high phosphorus fertilizer. And we'll talk about why we use phosphorus in a little bit. And then we reduced the humidity. So we still keep the humidity pretty high, as you would have noticed doing your monitoring in your journal, but not quite as high as when we had the plastic on. Then through the rapid growth phase. So the rapid growth phase starts when the true leaves appear. So for us, it was true needles, but that difference between the cotyledons and the true leaves. And at that point, so this was after reading week for us, at that point we switched to a high nitrogen fertilizer. Again, we'll talk why in a little while. We kept the temperature the same, aiming for about 20 degrees during the day, 16 degrees at night. We kept the lights on, so trying to give the trees 18 hours of daylight every day. Tricking them into thinking they have 18 hours of daylight. And then this is where the monitoring gets really heavy. So we wanted to monitor the growth of our seedlings and the environment in the greenhouse. And that's very important, because if anything's going to go wrong, we want to know right away so that we can mitigate the losses. So if we're going to lose some seedlings, we want to make sure that loss is as minimal as possible. So that's why we had all of you recording information. So if something goes wrong, we can look back at journal entries and say, okay, here's where the wheels fell off. So we're still monitoring. Dan's doing that for us all now, so he's keeping a really good eye on things and making sure that everything's still going well in the greenhouse and with all of your trees. All right, so our factors affecting seedling growth. So we've touched on this, but we'll just talk in a little more detail about the things that the trees need and that we supply in a greenhouse. So light, carbon dioxide, temperature, humidity, and nutrition. So if you remember this graph, we look at increasing any one of those factors and what kind of levels it can be taken to. So as we increase whatever we're increasing, we look at increasing the growth. And this is our goal. We want to increase the growth and we want to make sure that we're increasing the growth to a proper amount. And this is how we would measure that. So if we're not giving our tree enough of whatever, we will have limiting growth. So this means we're not getting as good growth as we want. What we want is, instead of being at that limiting where we're still on the upswing, we want to be right at that sufficient level. So as soon as that curve flattens, which is a term you're all familiar with now, it may make more sense than the first time we saw this diagram this semester, but as soon as that curve flattens and we get to that sufficient point, that is best case scenario. We're getting maximum growth and using the least amount of whatever is. As we increase whatever and move from sufficient high, we're not getting any increased growth. That curve is flattened. So increasing our output, but we are using more of whatever is, which is a waste of money and time usually. So we want to be closer to the sufficient end than the high end, but we want to be somewhere along that flat line. And of course, if we surpass the high level and we keep increasing whatever is, that's really fun for me to say, sorry if it's annoying, we start getting into excessive and lethal levels. So we start sacrificing growth. So with regards to our current world state, that's exactly what we want to see. We want to see that curve flatten and then start to go down, but we don't want to see that for our trees because we want to increase their growth and keep it as high as it can be. So looking at light first, obviously, this is what we're working towards this time of year, which is so nice. And this is what trees are looking for. So the natural sunlight gives them everything they need. And when that happens, this is basically what happens with trees in an outdoor setting and what we're mimicking in an indoor setting. So we can look at it from an indoor perspective. When our trees first started growing, or when our seeds first started growing, the first thing that happens is that root growth. And that's why we feed the trees 11-41-8 first. 11-41-8 means that the fertilizer is highest in phosphorus. Phosphorus is good for root growth. So we want our seeds to develop a good root system and, quite literally root or anchor themselves so that they can support shoot growth and growth above the soil. So you can see that curve of the root first, okay? So the roots grow first, and then right at the end of the establishment phase. So during the establishment phase, we have certainly some shoot growth, obviously, and a little bit of caliper growth. So the shoot growth is the primary growth up, the caliper growth is the secondary growth out or widening. I'm having trouble getting to my camera here. There we go. But once that establishment phase ends and we get into the rapid growth phase, you can see really get a huge increase in the shoot growth, which makes sense because we're gaining a lot of height at this point. And the root growth, still happens, but not quite as quickly. And the caliper growth isn't happening very quickly either. So this makes sense. If you look at where we're at now with your seedlings, you may have noticed that for the height data between March 16th and March 26th, there was a lot of growth in height, but not much growth in diameter. Really, over the entire time we monitor the height growth, we don't usually find any difference in the diameter, and this year was no exception. So it's really the shoots, that primary growth, that is expanding. And that's why we feed high nitrogen fertilizer at this point, because nitrogen is good for cell expansion. So it gives us that great growth. And then we can see at the end of the rapid growth phase, the shoot growth just completely bottoms out. So once that bud sets, there's no more growth. The primary growth now is stalled until the end of the dormancy period. So you can see what happens after the rapid growth phase when that bud sets and the shoot growth stops. You get the caliper growth, so that's when we really get the secondary growth or the expansion in diameter. And then the roots do another little peak as well. So the roots are the first thing to grow and the last thing to grow. And that's really important because we want to make sure we're feeding the roots during the hardening phase with phosphorus, and also giving the trees potassium at that point, because that helps them in the lignification process and just develop stress resistance. Can you come here? Come on, come here. I don't know if you can hear my dog, but she is running around like a maniac, and it's very hard to concentrate on trees when you're going crazy. Can you calm down? Can you calm down? She's not going to calm down. So, sorry if you can hear her stamping around. I'm trying my hardest to ignore her and stay focused, but obviously I failed at that. So this is the process that, or the timeline where this process happens in most greenhouses. We started our trees earlier, obviously, so we're moving that up a little bit, but it's still the same process, just not the same time of the year. All right, So when we look at light quality, obviously sunlight is best for our trees. We don't have the option to give our trees sunlight in the greenhouse, so we look at the visible light spectrum. And as a reminder, trees do best with red light and blue light. Okay, so that's what we give our trees, and we basically trick them into thinking that they're getting what they need from the sun by giving them the blue and the red light so that we get the best growth possible, but it's not the same as sunlight. So it's interesting that if we take our trees out of the greenhouse and put them right in the sun, they will burn. We'll literally give them a sunburn and they can die. So we need to get them used to the sun. So usually the first time we take them outside, we leave them in the shade for a couple of weeks, and then we gradually move them so that they're getting part sun and more sun and more sun. And then usually after a couple of weeks, you can put them into full sun, but you can't just take them out of the greenhouse and put them in direct sunlight. They've never had UV exposure. So it's usually lethal for them. And I just remember being so fascinated when I learned that, and I still think it's really cool, and it tends to surprise people. So it's one of those things that I really wish I could see your faces for, but hey, I'm glad to be talking to you, so I will take what I can get. All right, when we talk about seedling nutrition, there are 16 essential elements for plant life. We only need to worry about 13 of them. So carbon, hydrogen, and oxygen are available in sufficient amounts in the atmosphere, so trees don't have an issue absorbing them. What we need to worry about are the remaining 13 elements, and they are listed here. And of course they're broken down because we like to group things. For me, it makes them easier to study, so hopefully you find the same. But we have our macronutrients and our micronutrients, and the macronutrients are broken up into primary macronutrients and secondary macronutrients. And so all of the macronutrients are needed in higher amounts than the micronutrients, but the primary macronutrients, which are the top three in bold there, nitrogen, phosphorus, and potassium, they're needed in the highest amounts by trees. So NPK is how we describe fertilizers, and that's because these are the three elements that we're going to be feeding the trees most. Okay, then the secondary macronutrients, so calcium, magnesium, and sulfur. I remember this with the acronym CASMIG. It doesn't really make sense, but that's how I remember it. So if that's helpful for you, it's helped me for years and years and years now. And then we have our micronutrients, so our iron and boron and chlorine and molybdenum and things like that. And these are needed in lesser amounts by the tree, but they're still needed. So if you have a tree that is deficient in copper, and it's deficient enough for long enough, it's still going to die, but we don't need to give it huge amounts. So just as a reminder about our fertilizer rates or fertilizer analysis, three numbers. Again, these are representative of the NP and K. So the first number is the percent nitrogen. The second number is the percent phosphoric acid. And then the third number represents potassium, which is percent potash. And for those of you who missed the lecture, someone asked the same question I've always had: why is potassium symboled with a K? And that comes from the German word for potassium, which I didn't know until Monday when some students shared this. So I think it was kalium is the German word for potassium, and it was a German fella who first established the periodic table of elements. So that's really cool to know. So that's why potassium is symboled with a K, in case you had that query as well. So the one thing that's worth pointing out here is that, these three numbers never add up to 100%. So 20 plus 8 plus 20 is only 48%. That means 52% of this fertilizer is made up of other things. So it's going to be the secondary macronutrients and the micronutrients. So when we feed trees with fertilizer, we can be fairly certain that we're giving them the secondary macronutrients and the micronutrients, but what we are manipulating most is what we're giving them of the NP and K. And this is just an example of a fertigation schedule. So fertigation is fertilization and irrigation at the same time. So this is what we did in the greenhouse. Every time we watered, we fertilized. So we're irrigating and we're fertilizing, but instead of using two big words, we combine it into one really fun word of fertigation. Okay, and these are fertilizer rates, so the 11-40-1-8, the 28-20, and the 8-20-30, used throughout the different phases of growth in the greenhouse, and the range of parts per million or application rate just comes from what is accepted in industry. So folks who grow trees in greenhouses during the establishment phase will use 11-40-1-8, and they'll use anywhere from 50 to 100 parts per million. We used 100 this year because that's what we find offers the best growth for our seeds. So it's going to depend a little bit on where you are, what kind of substrate or soil you're using, what containers you're growing in, all that sort of stuff. So but usually the rule is that you stick within this range. Of course, we looked at that experiment in week 6 where they tried different values, and it was found to be successful to use a little bit more than this range, but we just stick with the 100 parts per million for 11-40-1-8 and 150 parts per million for 28-20. And then when it comes to irrigation, as a reminder, trees like deep, infrequent watering. This is why we had you water your trays to the point of saturation, so the heaviest the tray could get, filling all of the macropores and micropores with water and weighing it. And then from then on, you can just weigh your tray and know exactly when to water it. So that's handy so that we're not watering too much. And it also tells you how much to water, because you should water it until you get right back up to that saturation weight. So that will give it the deep, infrequent watering, encourage the roots to grow down all the way to the bottom of the container, and therefore establish as big a root system as possible. And then we've got our hardening phase. So this is after the bud sets, and this is where we stress the trees to, make them a little bit tougher. So hey, that's what's happening to all of us right now. We're being stressed, we're being pushed, we will come out stronger, and we just have to remember that everything happens for a reason. So the trees during the hardening phase are like, what are you doing to me? You have babied me, you've given me this perfect situation, and now you're putting me through this? Like, why? What are you doing? Why are you doing this to me? Because obviously trees think and overthink and go crazy like that. Little tangent of mine. But the hardening phase and putting them through that stress just helps them prepare for their dormancy period. So that is stressful on a tree and just helps it to get stronger so that when it shuts down, it can come back healthy in the spring. So we do all of that to the tree, and we continue fertilizing it. We give it 8-20-30 at this point, so high in phosphorus and potassium. Like I said before, feeding the roots and helping that lignification and stress resistance process. All right, so we talked about some stressors that our seedlings can endure. We talked about abiotic and biotic. So abiotic, as a reminder, is not living. So these are usually environmental stresses, and this is really where the Goldilocks principle comes in. So if we give our trees too much or too little of most things, it will be harmful for them. A lot of times the effects of too little are the same as the effects of too much, so it can be hard to know unless we're monitoring and keeping a close eye on things, whether we've got too much or too little. So this could be things like temperature, also nutrient deficiency or toxicity. So this looks at nitrogen. You can see that chlorosis or the yellowing of the seedling on the right, and hugely reduced growth. Then we've got water, too much water, not enough water. Both of them are bad for trees. Light levels, again, too much or not enough, can have a huge effect on growth. And then toxic chemicals. So this is photo that shows damage from fungicidal use that wasn't applied properly. Then we've got our biotic or our living agent. So in that lecture, we touched on some of these things. We talked mostly about fungi and insects. So that is what I would recommend focusing on for studying purposes. But we did cover a little bit on different things here. And then there was the seedling storage and handling. So this was not something that we actually ended up talking about, but there is a very detailed PowerPoint posted for you on D2L that I think gives you all of the information you need. Of course, once you look through it, if you have any questions, you know where to find me. But it just talks about the hardening process, so the developing of that stress resistance, so making the trees tougher before we put them into stressful stages like overwintering. So overwintering happens outside or in the freezer. freezer, and then they can be ready for spring shipping and planting if that is what your grower requires, or your buyer, sorry, requires. So there's a couple of points from this lecture that I just wanted to talk about. So what happens to our trees after they leave the greenhouse? One of the things that is discussed in that lecture is winter drying, and you may learn about this in other courses. I know Katrina talked about it in forest entomology and pathology, but it can be a difficult concept to grasp just from this image. So I just wanted to explain a little bit about what happens with winter drying. So basically it happens in late winter when we start getting sunny days and some warmth in the sun, but we still have usually a snow layer and frozen soil. If not a snow layer, then still frozen soil. But basically what happens is the top and the bottom of the tree aren't talking to each other. So the top of the tree is in the sun, it's warming up, it's like, oh yeah, I can wake up, it's time to break dormancy. And so the first thing that happens is transpiration. So the needles lose water, and then normally if the soil wasn't frozen at night, the needles would just get some water up from the soil. Well, they can't do that in the winter because the soil is still frozen, so there's no water movement there. So what happens with winter drying, we see this a lot this time of year. When the snow melts, you may notice on the side of the road, there's just a line of conifers, and in that line of conifers, there's a straight line where it's green on the bottom and brown on the top. And that's because this winter drying process has happened. So those needles then die. And when you're talking about, small seedlings, this can result in the death of an entire crop. So it is a big deal as far as greenhouses are concerned, because you don't want to go through all of the process of growing the seeds and then have the whole crop die over the winter. So some methods that folks use in greenhouses to overcome this: they store them outside, they lift them up off the ground and then cover them so that there is no transpiration happening in the foliage. Excuse me. And then the other way to avoid winter drying is to store inside in a freezer. So ideal cold storage in a freezer is right around -1 degree Celsius. Usually, it's nice to have a freezer because you have more control over the temperature, but obviously much more expensive than just plopping trees outside. I know all winter long I refer to the outdoors as the walk-in freezer. It's nice for, keeping leftovers cold, or freezing things, or keeping maybe some drinks cold, something like that. So that's one other way to overwinter seedlings, is if folks have a large freezer, then they can do it that way. Then our trees, once they've been through all of that, may or may not go through winter storage, but once they're done in the greenhouse, once they're done that hardening phase, they're ready for planting. And planting can happen in lots of different ways. So we have afforestation or reforestation, land reclamation, urban forestry folks. It's really important to grow trees for parks and boulevards and city trees and all of that sort of stuff. So tons and tons of uses of the hard work that growers put in. Okay, so afforestation, you can see we've got a field. This was an old farmer's field, so used for crop production, and this is what it looked like in 2007, and then 5 years later in 2012, starting to look like a little bit of a forest. So I think that we can all agree. Some of you may come from a farm background and prefer the look of the farm fields, and that's fine. Me personally, I would rather see trees. So this is just, the effects that that our work can have when we grow trees in a greenhouse and grow them successfully so that they can be planted out and do well for years and years to come. Another cool thing that is done with seedlings, this is a clonal site trial, and basically these are a specialized hybrid poplar, and they grow super fast. These trees are 2 years old. They have grown that much in 2 years, and I know you have nothing for scale, but it's huge growth. And this is helpful because the trial that this is talking about, they're looking at growing wood for biofuels. So for folks to heat their homes, and so when you're looking to do that, you want good growth as fast as possible. We don't necessarily care about the form or structure of the trees. We just want to produce as much wood as fast as we can. So lots of cool research and experiments happening with trees. As you know, we've talked about a lot of them this semester, and I hope you've enjoyed it. I sure, I don't know if you've noticed, but I kind of like talking about trees. They are one of the most fascinating organisms on Earth, in my opinion, and I really, really appreciate and I'm so grateful for the opportunity to talk about trees and to get paid for it, because otherwise my friends and family get really bored of me just talking about trees like all the time. It really, trees, bees, and fungus is all I ever want to talk about. So thank you for hanging out with me this semester. I know it's been a weird one. I have sure enjoyed it. I know we've gone through some challenges together and are still going through something unprecedented, but we are a team. We are doing this together. I am so, so grateful to have a continued opportunity to talk to all of you and to connect with you as much as we can. So I wish you nothing but luck in studying for all of your exams. If you come up with any questions for this course specifically, or anything at all that I can help with, please email me anytime. Please remember to do the things you need to do to keep yourself grounded. So, have regular dance parties. Like, if you're isolated on your own, you have no one to impress. You're probably in your pajamas right now. Be goofy. Put a fun song on and have a dance party. I really like Annie Lennox, Walking on Broken Glass. It's like one of my guilty pleasure songs, and I actually got up in the middle of the day the other day when it came on randomly, and I danced in my living room when my dogs looked at me like I was nuts. But you know what? Totally lifted my spirits. So don't be afraid to be goofy and weird, and enjoy the lighter side of things, because laughter really does help us get through. I hope that you are well. I hope that you are getting outside and washing your hands and doing the things that you need to do to get yourself through this. We can all get through this. We will get through this. And we will make history. You will tell your grandchildren about the time that we all stayed inside. So just remember that. I haven't lived on this planet long enough to consider myself wise, but I have been through enough that I can tell you that everything happens for a reason. And you can go through what seems like a really, really long period of really hard stuff and come out of it and look back on it and think, oh, wow, that really didn't last that long, or that really wasn't as bad as it felt at the time. And that doesn't minimize what we're going through now and the crumminess that it can hold. But it's just a reminder for you that you can get through this, and eventually you'll look back on it and you may remember it completely different than how you're experiencing it now. So hang in there. Talk to me anytime. That offer doesn't end next week when the semester ends. As we're going through this, if you need someone to talk to, if you want some positivity, if you want some other good, fun songs, silly songs to listen to, then hit me up anytime. I will still be checking my school email, and I would still love to hear from you. Okay? I miss you. I miss you all so much, but I'm so glad to be able to still connect with you. Keep well, wash your hands, be healthy, email me anytime.